Right. This video is of the first five true-false problems, and some of these are easier than others, so I'll go quickly through some of them. First one says, if f prime of c equals 0, then f has a local min or local max at c. And the answer to that is false because of this situation where you have like a cubic function that's always increasing, horizontal tangent line, derivative equals 0, but not a min or a max. Number 2 says, if f has an absolute min at c, then f prime of c equals 0. That's not necessarily true either, because look at this function, where the absolute min is here at c, but there actually is no defined derivative there because it's at the endpoint. Or think about this function, the absolute value function, where the absolute min is at c, but the derivative at c is not 0. So that is false. Number 3 says, if the function is continuous on the open interval from a to b, then the function attains an absolute max and an absolute min at some numbers in the interval. That is true. That is actually the, you know what, that's not true. That's not true. It would only be true by EVT if it were the closed interval from a to b. If you had a closed interval, then you would definitely have an absolute min and absolute max at some point in the interval. But with the open interval, you could have something like this, and so there's no way to find an absolute max or an absolute min. So the answer to that is false. So the fourth one is, if the function is differentiable and f of -1 equals f of 1, then there is a number between -1 and 1, that's what this means, such that f prime of c equals 0. Well, if the function is differentiable, then it also is continuous. So you've got continuous and differentiable function, which means that you have a mean value theorem problem. And if the y values from -1 to 1 are the same, then the average rate of change between them is 0, which guarantees some value c for which the instantaneous rate of change is 0. So that is true. For number 5, if the function is decreasing, if f prime is less than 0, then the function is decreasing. That is true because that is exactly what the derivative being less than 0 represents.